Hello, this is James Black again. I'm going to show you how to set up the VI specifically for our first lab using LabVIEW, our time-dependent data lab. A lot of the elements here will pop up again in the other VIs we create for our other labs. So I already have a VI open. Let's start with our block diagram. I have my tools palette and I have my context help. I don't have the functions palette up to save real estate space, but I can just right click. Here it is. And the first thing we want to do is use our DAC assistant. I've plugged in a USB 6009 DAC. Now I want to bring that into my VI. There are a couple ways of doing that, but a very common way, or the fastest way, is go to this Express menu, go to Input, and then DAC Assist. That's the DAC Assistant. Put that in there. Now it's asking what we want it to do. We want it to acquire signals. It's going to be an analog input, and it's going to be voltage. This device is my DAC, and we have 8 channels from 0 to 7. Let's just pick this first one. You can pick a number of these. The first few of them have differential inputs, while the last few only have single-ended. For this, we want differential, looking at the difference between our two leads, the positive and the negative. So let's pick that, or pick one. You can pick your own, but pick one of these first ones up here. Hit finish. So this comes up, and here is that channel that we just created. You can look over here at the connection diagram and note here that we have the positive on channel 2 and the negative on channel 3. So when you actually wire up your DAC from our signal generator, make sure you use these. I will show that in the video on how to set up the equipment. Just right now, no, that's there because we're in the spot where we can see that. But let's go back to this tab. Now there are a number of important things here. Let's start here. The voltage input. So this is the input range. And the lab handout is very specific about what signal we're going to give you. You need to set up your DAC so that it covers a specific range. And I'm not going to give you the answer here, but just remember the part that depending on our input resolution, we divide that range into a certain number of increments. So the better resolution, the better accuracy, to get that, we want to have a range that isn't far beyond what we're going to measure. So when you go through the lab handout, you find out the range you're actually interested in, you're going to want to adjust this so that it will certainly capture that without clipping, but that we're not wasting a bunch of our resolution and producing a bunch of additional error that we don't want. So that's this part up here. Here's that terminal configuration that I told you about. We want differential. In this lab, we are told to sample for a certain amount of time. So we are going to be doing N samples. The other option that we often use in this class is continuous samples. Here, it just runs in a loop until we tell it to stop. But if we want it to run for a certain amount of time, then we pick N samples, and we got to come over here then to samples to read and rate. And we need to set these so that it will sample for as long as we want it to. Just as an example, here we have a rate of 1 kilohertz, and we're reading 1,000 samples. So since we're taking 1,000 samples per second, and we're taking 1,000 samples, we're going to measure for exactly 1 second. This may be the setting you need. It may not. I'm not going to give that to you right now. You need to look at the lab handout. You need to think about everything we talked about with the sampling rate, with Nyquist's theorem, to pick a sampling rate that's going to work for the possible frequency ranges you might get. And then based on that, you're going to need to set a certain number of samples to measure for how long you're supposed to measure. So let's just assume we've set all those to what they should be, and we hit OK. Now we are here. Where did my context help go? I thought I had that open. It disappeared. Oh no, I'm sorry. It's just, so once you say OK, it takes a little while to configure the DAC, and that's what it's doing right now. It should say building VI there. It says building VI. Should be ready here in a couple seconds, and now it's ready. There are a number of options here. If you look up there in the context help, we have rate, number of samples. These are those same things I was talking about on that screen we were just at. If, for example, you just want to, you know you're going to be sampling at a certain rate and a certain number of samples for all your measurements, you can just set that back where we set it and leave it, and it will be fine. But one of the requirements that you're supposed to do in the lab is to sample the signal we give you, meeting all those requirements we say in the lab handout, and covering all the theory that we've talked about in lecture. And then after that, you need to intentionally make a mistake and undersample, just to see what the outcome of that is. So because you're going to want to change that rate and the number of samples, it would be good to give you those controls. To get that, to get any control, just come back over here and hover over, oh, it's not picking what we want. We should go back over here and pick the automatic tool selection. So if we do that, it should now, it should allow us. Okay, I thought something popped up there, but what we need to do is right-click over that node that we see is rate. Then come here to create control, and it pops up. See, now it's popping up. That's what it should have done before. I don't know why I wasn't doing that before. See, it does it now. For some reason it wasn't doing it, but we got it up anyways, and now here we want to get the number of samples. So we right-click, create control. Now what that does is this gives us on the front panel the ability to enter a rate. If we want to make one measurement and change a rate and make another measurement, we can do that from here, and we don't have to go back into that screen and go through all the reconfiguring of the DAC again. So let's go back here. There are some other useful things that we're going to need here. The main thing would be just to think about what we're going to do with our data. And we're going to want to do a couple things with that. The thing that the lab handout is very clear about is you need to collect this data. And we usually do that by writing to a spreadsheet. So come out here and right-click, and then go to this antiquated floppy disk image here, the icon, and come over here to Write Delimited Spreadsheet. That's what we want to do, and we place this here. You can see it's telling us about all the options. We're going to want a lot of these. Again, we're going to do the right-click on Create Controls. So it pops up, it tells us this is format. That's one we want. Let's create a control. That allows us to specify the significant figures we're going to use. The file path is going to be a critical thing. This tells it where to save the data. So we want to right-click, Create Control. You can drag and put these wherever you want. Now, we have two options here for 2D and 1D data. So this is whether we want two-dimensional or one-dimensional data. And we're just going to spit out a series of voltages that are the amplitude of our signal. So it's just going to be a one-dimensional data. Later in this semester, we'll do some 2D stuff. Right now, it's one-dimensional. You see it's anticipating that we want to wire it up. We have the wiring tool. So that is what we want to do. Let's click that and let's drag it over here to data. That wires that up nicely. Now we want to append to file. That append to file allows us to, so we're going to be taking, just use that example. Right now we're set up to take 1,000 samples in a second. If we don't want it to just keep writing over the same cell, then we want to append to file. So LabVIEW likes to write in rows. So it'll just go out to a new cell in each row for every one of those samples if we pick this append button. So we want to go to append, create control, and there it is. This we will need to, I'll show you that here in a minute because we're going to need to do it for more than one thing. Let's go back to our delimited spreadsheet. So something else we want is transpose. So let's go down here to the transpose and let's doing that again where it's not popping up. There you go. There's the transpose. Right click, create control. Because I just told you that LabVIEW likes to give us the data in rows, but we're going to be working with this in Excel. And Excel likes to work in columns. It only gives us a limited number of rows, but we have virtually unlimited data if we put it into a column. So this transpose will take that data in a row that LabVIEW creates and transpose it so it's in a column like Excel likes. I think that is all that we need up here. So let's go over to our front panel and see what that looks like now. We have our spots where we can adjust the rate, where we can adjust the number of samples. We can adjust our format. So here it's going to give us out to the thousands. Say we want to take this out to 6 significant figures, we would just change that 3 to a 6. And here, if we want to append to file, we just click that to turn it on. And if we want to transpose, which we do, we want to turn that on. There's one more thing that we're missing that we want to show up on our block diagram, but this is generally easier to get to show up if you start from the front panel. You can go either direction. What we want is a graph. And there are a couple options here. We want a waveform graph. The waveform chart, it keeps track of our data over a longer period of time, and we will use that in one of our later labs. But for this, we just want to see that data that we measure in one chunk and then have it reset for future measurements. So we'll use this. We can just drag this over here, set it on our front panel. Now if we go to our block diagram, we see it's popped up. And we may need to move where that is. And we just want to wire this right off of our data. It just automatically splits. So our input is going to go to our graph, and it's also going to go to our spreadsheet. The last thing we need to do is to specify a file path. You can click here. I recommend you use a USB thumb drive. I'll just save it here. If you pick a location and you give it a file name, let's call it test, and say OK, that all should populate there. we should be ready to test. Oh, there's one last thing here. It'd be good to specify. I like to specify CSV. You can specify it as a text file. You can specify it as an Excel file, but what works best is just a CSV file, a comma separated value file. The text file, it is more difficult to import it. So this is just the quickest way, works smoothly. We should be good to go for a test. Let's run a test. Got some data, and this looks pretty good. So we took a full second of measurements, and the signal that I sent into this was a sine wave, and it had a DC offset. I can't remember what numbers I put in, but it looks like that. So this is really a lot of data crammed into a small space here. Let's go and check out this file. It'll be easier to manipulate it there. So let's go to where I saved that. Now we see I actually produced what I wanted to. Let's open that. It's already planning to open it in Excel. Hopefully we have all that data in a single column. Looking good so far. Let's just plot some of this. And part of what I'm realizing right now too is I think my signal I just put in something to get the signal generator running. I think I put in a fairly high frequency signal, and my sampling rate is not high enough, but we can at least see that it is a sine wave with a DC offset. So it's collecting good data. Once you do a test like this, so at this point you would want to adjust your sampling rate and the number of samples taken so that you are satisfying the Nyquist theorem and so that you're satisfying the requirements of the handout. And once you adjusted everything to what it should be, let's say you needed to adjust this up to 3,000. And say you also wanted to, next time you opened up your file, you want it to be set to this, you can come up here. Where is that? There's an option to make current values default. There it is. So now if you shut this down and open it back up again, these values will be there. That has thrown off some students. They thought they got everything set up, they needed to shut down for some reason, and they come back to it later and they don't anticipate that the values will go back to default. But if you do this, you can set those as default, and that's what will pop up. That's it for this.